Hello, my esteemed viewers. In this tutorial, we continue with our machine learning fundamentals. And in this tutorial in particular, we discuss and we will just clearly understand even machines will also commit mistakes. And the mistakes are increasingly called as bias, variance, overfitting, and underfitting. So we will clearly explain these concepts before we deeply dive into machine learning concepts. It's a precursor. This particular tutorial comes as a precursor to machine learning. Imagine we have following sets of data: height and weight of students ready for army recruitment, cholesterol content and BP level of people, maybe from healthcare or from a diagnostic center, load and deflection values are drawn from a civil engineer, pressure and discharge values in a water conduct, age and number of hours of mobile usage in a day by people, milk production over past 25 years in a city, number of steps traversed or number of hours of jogging and the amount of energy burnt, so on and so forth. And for the matter of simplicity, we choose the second example data and we will try to represent that on a graph. So we have this amount of data, BP expressed as millimeter per Hg of hydrogenum, and cholesterol milligram per deciliter of blood. And these are all the data samples that we have got. And lower, and from the graph itself, we will be able to say vaguely or roughly that the lower the cholesterol, lower will be the BP, and higher the cholesterol, higher will be the BP. And for these things, and there is a threshold for this BP. Anyway, as cholesterol increases beyond this particular point, there is no appreciable change in the value of the BP. Therefore, we fail to find out some kind of a solid relationship. We can use this graph to predict the BP level given the cholesterol content. However, if this is the cholesterol content, because this is the thing that we have, and then we can say this is to be the BP of the person by just drawing a horizontal vertical line, and from drawing a horizontal line from over there, and whatever the point that intersects, that will be the value of the BP. And if we can get a mathematical equation but which really describes the relationship between cholesterol and BP, then we would have predicted exactly. Since the variation of BP with respect to cholesterol cannot be captured by means of a tailor-made equation, by means of a closed form solution, we take a recourse to machine learning algorithms. In this case, we are unaware of mathematical formula. Therefore, we will use say two machine learning methods to approximate this kind of relationship. As per the procedure, we split the data in the ratio 70:30 into two data sets. We will collect the data, shuffle the data, and we will select randomly 70% of the data for the training of the machine algorithm model and testing, and we will retain 30% of the data for testing the machine learning algorithm. The black points is under the testing set, and the red points are under the test set. This is the training set and this is the test set. We implement the first algorithm, called linear regression algorithm, as the first algorithm. This algorithm is based on principle of least squares. Principle of least squares would say the sum of the squares of the errors from the model to the actual data should always be minimum. So that is the theme of principle of least squares. Using this particular principle, we can fit a straight line depicting the relationship. Anyway, straight line over here doesn't bend like an actual relationship. because it is linear, and any number of turns and twists given to this particular straight line will never fit exactly the BP value, or the relationship between cholesterol value and BP value, or cholesterol and BP. None of the straight lines are able to fit the true relationships that is shown by the curved line. In fact, finding a line, finding various positions of the lines in the training algorithm iteratively would only would only reduce to finding the intercept over here and slope of the line. That's what we find whenever we fit a straight line. That means this is the intercept, vertical intercept, that is let us say B, and this is the M, the slope of this particular line. Therefore, this particular regression line will receive an equation something like BP or Y equal to mx plus B, or mx plus C, where C is this particular intercept. So therefore we will use the training set, and we will train and retrain the model iteratively to arrive at some kind of a position, some kind of the value of C and some value for M, wherein the squares of the errors is the sum of the squares of the errors is minimum. Anyway, it has failed. The inability of a machine learning algorithm, that is linear regression algorithm over here in this example, to capture the true relationship between the variables, that is cholesterol and BP, is called as the bias. Therefore, machine learning algorithm has erred over here, unable to fit exact relationship, or the real relationship that exists between two variables or two attributes. Now we will consider a non-linear machine learning models like artificial neural networks. And of course, my respected viewers need not have to worry, because we will be clearly explaining the working of artificial neural nets in our forthcoming tutorials. And we have taken a recourse to using artificial neural network, and we will train this particular model using the training set, and interestingly we will find a best kind of a fit, which looks like something like this, which passes through all the points, and such a line is a squiggly line due to its undulating variations. It passes through all the points, and remember, we are using the training set. Unlike linear regression line, the curved line fit the training set because it has very little bias. Now ANN model as a machine learning model is said to possess very minimum bias, or very little bias, because it is able to fit the given training set of the data very well. And as far as we can compare the two learning algorithms by just measuring the sum of the squares of the distances from the predicted value and actual value. The predicted value is by the red line. We will go on putting the values of let us say cholesterol value, and we will use the equation of this particular line, and we can predict the BP value. But actual value or values are shown by this block spots, and there exists some kind of a distance between this point and this line, and this point and this line, and if we square, that is nothing but the error. Since if you take this is a positive error and this is a negative error, and we will get and if we simply sum these errors, say these differences or the heights or the distances, there are chances that the positive distances may cancel away. Therefore we will square the distances. That is the philosophy of least square errors. And we compare the two learning algorithms by just measuring the sum of the squares of the distances from the predicted values and the actual value. So as far as this squiggly line is concerned, which is being put up by artificial neural network model, there happens to be no error at all, because this particular line passes through all the points, hugging all the points. This can be done by finding the square of the distances. Okay, this is how we find the errors. And it is important to note that the curved line fitted by ANN fits the data so nicely that there is no distance left, there is no error left. And continuing further, as far as this example is concerned, ANN is the best. Regression algorithm has failed miserably because regression algorithm showed huge bias, while absolutely there was no bias as far as the ANN algorithm is concerned, machine learning algorithm is concerned. But we have implemented the algorithm using training data set only. This is a very important thing. And if we try both the models with the test data set, that we have kept it apart, 30% of the data we have kept apart only to test the models, and we find interestingly the linear relationship showing very less error when compared to the non-linear relationship or squiggly line that is being put up, that is being fitted by ANN model. We see that the straight line developed by linear regression algorithm is better when compared to this curved line. Even though ANN did a good job of fitting the training set exactly, it did a terrible job fitting the test set of data. In other words, it is in essence, in machine learning terminology, the difference in fits between the data sets is called as variance. Variance. It is a mistake, it is a relative mistake done by two machine learning models, and this is called as variance. In other words, that is, ANN showed low bias and high variance. Low bias for training data set, while high variance for the test data set. In other words, it is hard to say how well the curved line developed by ANN perform for the data that may turn up in later points of time. That means here the linear regression model showed very less error when test data is presented, and it is to be clearly remembered that the test set data has not been shown to the model earlier. Okay, and the model will be developed using only training set. Therefore, it becomes a new data, it becomes a unseen data as far as both the models are concerned. So in the Mealy, ANN showed the high bias for the training set and high variance for the data set, for the test set. Low bias for the training data set, while high variance for the test data set. But the straight line has low variance because it showed lower value of some of the squares of the distances, but it has high bias. In other words, it is hard to say how well the curved line developed by ANN perform for the data that may turn up in the later points of time. That is, the new data that may come up at the later point of the development of the model. And this is the thing. In other words, the straight line will only give good predictions and not very precise predictions, of course, because there is an error. There is an element of error here too. But it gives consistently good predictions for set of data which was not seen by the algorithm earlier. That is a very interesting point about this particular example. We say that ANN overfits because ANN doesn't show any kind of error for the training data set, but it shows very high error whenever test data is fed. Test data is fed to the developed model. That is, ANN showed no error as far as the training data is concerned, but it showed very high error as far as whenever test data is used, because ANN fits the training set very well through a curved line, but not the testing set. Yeah, we say ANN overfits. So any machine learning model set to commit overfitting if it does very good fitting for the training data, but it miserably fails for the test data set. In machine learning, the ideal algorithm will show low bias and can accurately model the true relationship. It will also have low variability. So the model should be something like this, which was drawn earlier in the beginning of the explanation. See, this particular line is the true relationship, which is a curved line. Of course, maybe a parabola, maybe a third degree curve, maybe a second degree curve, which maintains minimum distance both for test data as well as training data. That is low bias and low variability. However, it is very difficult to achieve such a relationship by any of the models, because every model will either commit bias or variability. And such ideal algorithm produces consistent predictions across different data sets. To achieve that, we need to find a model that is a compromise between a simple model like a line and a complex model like this. That means we have to find a model. We have to consider different models, and we have to do computational exercises by using training data, and by using testing data we need to find out if at all any variability is there, and by using training data we should see if at all any bias is there, and we have to strike a compromise by finding a model that has low bias and low variability, which is the demand from any machine learning algorithm. And of course, 3 methods are available in order to find the best machine learning algorithm that befit the given data set. They are the regularization, the boosting, and the bagging. These 3 are the methods available in order to find. That means all these 3 methods will check the errors, will check the bias, the magnitude of bias and magnitude of variability among host of machine learning algorithms, and whichever will give some kind of a median kind of a value both for bias as well as variability. That is the best machine learning algorithm. Therefore, in this module, in this tutorial, we have understood as to what bias is, as to what variability is, as to what overfitting is. Underfitting is not explained, but underfitting is shown by those models which will show great bias and great variability. Of course, such a model is to be discarded. Okay, threadbare. You should be discarded, threadbare. So with this, we will complete this rudimentary discussion, or discussion of a very much important fundamental, that is the mistakes committed by machine during its learning exercise. So with this, we will close this tutorial and we will come up with the next tutorial. And until then, bye. And if you liked this video, kindly subscribe to my channel. Thank you.